Hello, my friends. Hello, my friends. Now, it's common knowledge that I'm a pretty versatile guy, but even I am not as versatile as oil or water. Here is a potato I boiled in water. Delicious. Now here I have tiny bits of potato I boiled in oil. Very delicious. Both potatoes were cooked in similar ways, but different ingredients. So naturally, one has to ask, if oil and water are so similar, then why don't they ever go out on a date? Welcome to another Tree in Review, and today we're going to review the romantic compatibility between oil and water. Here I have a transparent cup for seeing purposes. And now I'm gonna pour some water into the cup. And now I will pour a little bit of oil into the cup. And here is my spoon for mixing. Now, if all goes well, they should mix together into one solid liquid. But what is this? All the oil is floating to the top. Why oil? Why can't you just give water a chance? Water is nice and caring, and you could swim in it, and you can drink it when you're thirsty, and you always got water to clean yourself. I just don't understand. Wait, let's hold up for a minute. Okay, this is nothing personal. This has something to do with chemistry. Water molecules are polar. This means that a water molecule has an uneven charge. One end would be negative, while the other is positive. This is good for other molecules like salt or sugar that easily dissolve in water because of the polarity. Unfortunately, oil is what you'd call as nonpolar. This means it has an even charge all around. Not just that, oil is kind of intimidated by water. It's what you'd call hydrophobic, or fear of water. This means that instead of mixing, oil is repelled by the water molecules, and this is mainly due to the polarity. Well, that makes sense, but it doesn't explain why oil has to separate itself so much from water to just float to the top. That's a good question, my friend. Well, this has a lot to do with density. Now, density refers to the mass present per unit volume. So for water, the density is 1 gram per cubic centimeter. But oil has 0.93 grams per cubic centimeter. This means that the density for oil is much lighter, by a little bit, than water, so it floats to the top. Nothing personal, just chemistry. So now, we should review. Should oil and water be in a committed relationship? Well, I have to say no. No, I do not recommend. I think their relationship will not work out. They will mix kind of like oil and water. They will not. So I review the relationship between oil and water as an F.